Hello everyone, welcome back. In today's lesson, we are diving into one of the most important topics in Microsoft Azure: security, privacy, compliance, and trust. Here, let me ask you a quick question. If someone asked you today, how does Microsoft Azure protect millions of users and organizations around the world? Would you be able to answer confidently? By the end of this lesson, the answer will be yes. In this chapter, we are going to take a deep dive into Azure security architecture. We will explore how Azure verifies identities, protects data, secures applications and infrastructure, enforces governance policies, and helps organizations meet global compliance requirements. You will also learn one of the most important concept: zero trust, a security approach based on the principle of never trust, always verify. Before we jump into the technical concepts, let's take a quick look at our roadmap for this lesson. By the end of part 3, you will have a solid understanding of how Microsoft Azure protects cloud environments and why organizations around the world trust Azure with their most valuable data. Okay, let me ask you a question. If you were migrating your company's applications to the cloud today, what would be your biggest concern? Would it be security, or protecting customer data, or meeting compliance requirements, or making sure only the right people have access? The good news is that Azure has built-in services to address all of these challenges, and that exactly what we are going to explore in this module. We will start with the shared responsibility model, one of the most important concepts in cloud computing. You will learn exactly which security responsibilities belong to Microsoft and which ones remain your responsibility. Next, we will learn Microsoft Entra ID, Azure's identity and access management service. You will learn the difference between authentication and authorization, how single sign-on works, why multi-factor authentication is so effective, and how Azure verifies identities before granting access. From there, we will move into defense in depth, where you will discover how Azure uses multiple layers of security instead of relying on a single protective barrier. You will see why even if one security layer is compromised, the remaining layers continue to protect your environment. After that, we will look at Azure governance and compliance. You will learn how organizations enforce security policies, organize resources, maintain compliance with industry regulations, and manage large Azure environments consistently. We will also explore Microsoft Defender for Cloud, Azure Monitor, Azure Advisor, DevSecOps, and finally, one of the most important modern security strategies, that is Zero Trust. You will learn how organizations continuously verify every user, device, and access request instead of automatically trusting anyone inside the network. The pillars of digital trust. Before any organization moves its applications or data to the cloud, there is one important question they always ask. Can we trust the cloud? Okay, think about it for a moment. Banks store financial records in Azure. Hospitals store patient information. Government agencies manage sensitive citizen data. Large retailers process millions of online transactions every day. Would any of these organizations move to the cloud if they didn't trust it? The answer is absolutely not. That's why digital trust is one of the most important foundations of cloud computing. Digital trust is not a single Azure service or a single security feature. Instead, it's built on several interconnected pillars that work together to protect your organization, your users, and your data. In Microsoft Azure, these pillars are security, protecting your applications, infrastructure, identities, and data from cyber threats. Privacy, giving you control over how personal and sensitive information is collected, stored, and processed. Compliance, helping organizations meet regulatory standards such as GDPR, HIPAA, ISO 27701, and many others. Transparency, providing clear documentation, audit reports, and visibility into Microsoft's security and compliance practices. Shared responsibility, clearly defining which security responsibilities belong to Microsoft and which remain with you, like customer. Think of these 5 pillars as the legs of a table. If one leg is weak or missing, the entire table becomes unstable. In the same way, organizations build trust in the cloud by strengthening all 5 pillars together, not just one or two. Okay, we have introduced the pillars of digital trust. Let me ask you, what does it actually mean to trust the cloud? Many people think cloud trust comes from a single security feature like encryption or multi-factor authentication, but that's not how it works. Cloud trust is not a single feature. It's a framework built on multiple pillars that work together. For Microsoft Azure, To earn the trust of millions of customers worldwide, it must consistently deliver excellence across 5 key areas: security, privacy, compliance, transparency, and shared responsibility. Okay, let's imagine you are renting an apartment. The building owner is responsible for keeping the building itself secure. They install security cameras, maintain the entrance, secure the lobby, hallways, elevators, and ensure the building is structurally safe. But once you are inside your apartment, who is responsible for locking your front door? You, right? Who decides whether to leave valuable items lying around? It's you only, right? In the same way, Microsoft cloud computing works. Microsoft is like the building owner. Microsoft secures the physical data centers, networking infrastructure, power systems, cooling, hardware, and virtualization platform. You, like the customer, are responsible for protecting your virtual machines, applications, databases, identities, passwords, permissions, and the data stored in your Azure environment. So, cloud security is a partnership. Microsoft provides a secure foundation and you build on top of it by following security best practices. Okay, now let's explore one of the most important concepts in cloud computing, that is shared responsibility model. If you move your application to Azure, who is responsible for securing it, Microsoft or you? Here the answer is both. Cloud security is a shared responsibility between Microsoft and the customer. However, here the important part, the division of responsibilities changes depending on the cloud service model you choose. The more Microsoft manages for you, the less you have to manage yourself. Let's see how it works. Infrastructure as a service, IaaS. In infrastructure as a service, Microsoft provides the foundation. Microsoft is responsible for securing the physical data centers, networking infrastructure, storage systems, servers, and the hypervisor that runs the virtual machines. But everything inside your virtual machine is your responsibility. That includes operating system, installing security patches, configuring applications, protecting your data, managing user accounts, and securing identities. Platform as a service, PaaS. Here, Microsoft takes on even more responsibility. In addition to the infrastructure, Microsoft also manages the operating system, runtime environment, and middleware. That means you don't have to worry about OS updates or server maintenance. Instead, you focus on building and deploying your application. Your responsibility is the application itself, the business data it uses, identity management, and application configuration. This allows developers to spend more time writing code instead of maintaining servers. The last one, software as a service, SaaS. In this model, Microsoft manages almost everything from end to end. The infrastructure, operating system, application platform, and software itself are all managed by Microsoft. You manage your users, their permissions, and the business data stored in the application. Here the best example is Microsoft 365. Microsoft manages the Exchange online servers, applies security updates, performs backups, ensures high availability, and protects the infrastructure. But suppose your company wants only managers to access confidential emails or wants to restrict who can delete messages. Who configure those permissions? You will configure it. Customer will configure it. Microsoft secures the service. You secure how your organization uses the service. That's the shared responsibility model in action. Here, easy way to remember, like as you move from IaaS to PaaS to SaaS, Microsoft responsibility increases from infrastructure as a service to software as a service. The Microsoft responsibility increases, your operational responsibility decreases. Imagine you are using Azure virtual machines. Who is responsible for installing Windows security updates? Microsoft or you? The correct answer is you, because Azure virtual machines are an IaaS and the operating system is the customer's responsibility. Now another question. If you are using Microsoft 365, who patches the Exchange online servers? Who, like you or Microsoft? Yes, that's right, Microsoft. Because Microsoft 365 is a SaaS, software as a service. Identity is the new perimeter. Now we are entering one of the biggest shifts in modern cloud security. If you are inside the network, like in a previous model, in older days, like in on-premises environment, if you are inside the network, you are trusted. But in today's world, where employees work from home, coffee shops, airports, and personal devices, can we still trust someone just because they are inside the network? The answer is no. That's why cloud security has completely changed. Identity is the new security perimeter. In modern Azure environments, identity has replaced the network as the primary security boundary. Instead of asking, are you inside the network? Identity is the new security perimeter. In modern Azure environments, identity has replaced the network as the primary security boundary. Instead of asking, are you inside the network? We now ask, who are you? And can we trust your identity? Every access request is verified. no matter where it comes from. If you compare traditional versus modern model, in traditional model, like in old on-premises world, firewall protects the corporate network. Once you are inside, you are trusted. Outside, you are blocked. So the entire security model depended on network location. But in modern cloud scenarios, in Azure, the modern identity becomes the security layer. Every login is verified, every request is evaluated. Trust is never automatic. Even if you are inside the company network, you still must prove who you are. Like here, how Azure actually checks. When a user tries to sign in, Azure evaluates multiple sign-ins: identity, password or credentials, multi-factor authentication, device health, location, risk score. Is this behavior unusual? Only after all these checks are satisfied, then only it will grant the access. Okay, let's imagine you entered your username and password correctly for Azure portal, but you logged in from a new country, an unknown device, a suspicious IP address. Now what happens? Even if you entered correct password, Azure may require multi-factor authentication approval, asks for biometric verification, or completely block the access. Why? Because identity is no longer just about passwords. It's about context and trust signals. Identity is the new perimeter in cloud security. Network location is no longer trusted by default. Azure evaluates identity plus context before granting access. Identity. First, security. Okay, let me ask you a simple question. In the traditional IT world, what did organizations trust? They trusted the network. Traditional model, like in the traditional on-premises model, a firewall protected the corporate office network. If you are inside the network, you are trusted. If you are outside, you are guilty. In the traditional model, a firewall protected the office building. Once inside the network, users were trusted. In the modern cloud world, identity is the new firewall. Every access request must be verified regardless of where it originates from. So here you can imagine you are working from home. You enter your correct username and password, but Azure detects something unusual. You are logged in from a new country, the device is not previously registered, the login behavior is unusual compared to your history. What happens? Even though your password is correct, Azure may require multi-factor authentication approval. It requests additional verification or block access completely. Why? Because in modern security, identity alone is not enough. So context matters too. Here you can Simply you can remember like traditional security, network based trust, modern security, identity based trust. Authentication versus authorization. In cloud security, authentication and authorization, these two terms may sound similar, but they answer two completely different questions in access control. Authentication means who are you? Let's start with authentication. Authentication is all about identity verification. Before granting access to any system, Azure first verifies your identity. It's like by entering username and password, or fingerprint, or biometric scan, or multi-factor authentication. Authentication apps like Microsoft Authenticator. By using all this, you are giving authentication. You are telling like who are you. You are verifying by yourself. Authorization means what can you do? Authorization happens after authentication is successful. What are you allowed to do? In authentication, who are you? But in authorization, once that authentication is successful, in authorization, what are you allowed to do? What can you do? Just because successfully logged in does not mean you can access everything. Azure checks permissions and determines what resources you can use and what actions you can perform. Here let's understand with one example. Imagine you work in a company. You log into the system successfully using multi-factor authentication, MFA, that is authentication. Now you try to access different systems. You can access payroll data because you are from, imagine you are from HR department. So you can access payroll data. But you are blocked from the finance database because you are not part of the finance team. That is the reason it is blocking. So here login is success, authentication is success, but here access control means authorization is blocked because you are from different team, you are from HR, but you are trying to access finance database. Microsoft Entra ID. Microsoft Entra ID. Now let's talk about the heart of identity in Microsoft Azure. Microsoft Entra ID. Let me start with a quick clarification. You may still hear the term Azure Active Directory, but Microsoft has now rebranded it as Microsoft Entra ID. Microsoft Entra ID is the central identity and access management service in Azure. It controls who can access what across cloud applications, on-premises systems, and even external partners, all from a single identity platform. What does Microsoft Entra ID actually do? think of it as the digital identity backbone of Azure. Instead of managing separate usernames and passwords for every application, Entra ID centralizes identity into one secure system. That means one identity per user, one secure login system, one centralized control plane. Single sign-on. Single sign-on allows users to sign in once and access multiple applications without logging in again. For example, you sign in once using your corporate credentials and immediately you can access Outlook, Microsoft Teams, SharePoint, Azure portal. But here it will not ask you for authentication again and again. So no repeated logins, no multiple passwords. This improves both security and user experience. Multi-factor authentication. Even if an attacker steals your password, that alone is not enough to access your account. Why? Because Entra ID requires additional verification factors such as a mobile authenticator app approval, a phone call or SMS verification, a fingerprint or biometric scan. So even if credentials are compromised, access is still blocked. Without this second factor, this is one of it will not be compromised. It will not be accessed, it will be blocked even if password compromised. This is one of the strongest protections against phishing attacks. Conditional access. This is where Azure becomes intelligent. Instead of allowing or blocking access blindly, Entra ID evaluates risk in real time. It considers user location, device health, user behavior, risk level. Based on these signals, Azure can allow access normally. It requires multi-factor authentication or completely block access. This is a key concept of zero trust security. B2B and B2C identity. B2B, business to business. With B2B, you can securely invite external partners, vendors, or consultants into your organization. They use their own identity but are governed by your security policies. B2C, business to consumer. With B2C, you can manage customer identities at scale. For example, users logging into a retail website or mobile application using social accounts or email-based authentication. Both B2B and B2C are handled through the same identity platform, Microsoft Entra ID. You log in once in the morning using SSO. Throughout the day, you access email, Teams meetings, project files, and Azure resources without login again. But if you try to log in from an unfamiliar device in another country, conditional access may require multi-factor authentication or block access entirely. This ensures both convenience and security at the same time. If your password gets stolen but MFA is enabled, can an attacker still access your account? No, right? Because authentication requires multiple factors, not just a password. So here you have to remember like Microsoft Entra ID. Identity and Access Management Service, SSO. One login for multiple applications, MFA. Extra layer of security beyond passwords. Conditional access, smart risk-based access control. B2B, B2C, external identity management scenarios. Defense in depth. Let me start with a simple question. If one security control fails, should the entire system become vulnerable? Of course not. And that is exactly why Azure does not rely on a single layer of security. Instead, it uses multiple layers of protection stacked together. This concept is called defense in depth. What is defense in depth? Defense in depth means security is built in layers. Each layer protects a different area. If one layer is compromised, others still protect the system. Think of it like a series of security checkpoints. An attacker must pass through multiple barriers, not just one. This significantly reduces risk and limits damage. The 6 layers of defense in depth. Azure security is designed around 6 layers. Physical security, identity and access, perimeter security, network security, compute security, data security. Let's go through each one. Okay. Layer 1, physical security. Before we talk about firewalls, encryption or identity, we need to understand something very important. Security in Azure starts even before a single virtual machine is created. That is physical security. Physical security is all about protecting Microsoft's global data centers, the places where Azure actually runs. These data centers are highly secured facilities designed to prevent any unauthorized physical access. Biometric access controls. At the entrance of these facilities, access is not simple. Employees must pass through strict verification systems such as fingerprint scanning, retinal or iris scanning, secure identity verification checkpoints. So, even Microsoft employees cannot enter freely. They must be explicitly authorized. Next, security guards. 24/7, 365 days. Every Azure data center is protected by trained security personnel. These security teams operate 24 hours a day, 7 days a week, 365 days a year. There is always active human monitoring at every facility. Surveillance systems. In addition to physical guards, Azure data centers are covered with full perimeter CCTV monitoring, continuous surveillance systems, motion detection and access tracking. Every movement inside the facility is monitored and recorded. And there is no access to the customers. Here, like customers never get physical access to Azure data centers. This means no customer can walk into a server room, no external access to hardware, no direct interaction with physical infrastructure. This creates a strong separation between customers and the underlying infrastructure. If someone cannot physically access the hardware, they cannot directly compromise the cloud infrastructure. This is the foundation of trust in Azure. Physical security is entirely Microsoft's responsibility. Customers never manage physical infrastructure. Includes biometric access, surveillance, and controlled entry. Layer 2, identity. This is one of the most important layers in modern cloud security. Even if credentials are stolen, Azure is still protected. Why? Because identity security is not based on passwords alone. It is based on multiple layers of verification and trust signals. What does the identity layers do? The identity layers ensures that only legitimate users and services can access Azure resources. This is managed by Microsoft Entra ID, which acts as the central identity system for everything in Azure. But identity security goes far beyond just login credentials. It includes multi-factor authentication, risk-based conditional access, least privilege access control. An employee's password is stolen through a phishing email. The attacker now tries to log into Azure portal. From the attacker's perspective, it looks easy. They have the correct password. But in Azure, that is not enough. They need like multi-factor authentication and conditional access. These all the things are there, right? As soon as the login attempt happens, Azure evaluates multiple security signals. Is this a known device? Is this a trusted location? Is this login behavior normal? Does the user need MFA verification? Now Azure triggers additional security checks. Approval request in Microsoft Authenticator app. Fingerprint or biometric verification. Location-based risk analysis. It verifies these all the things. If these all are satisfied, then only it will allow. But if it will comes to biometric verification, fingerprint, it has to come to you only, right? So this is not happen. It will be blocked. Even though the password was correct, the login fails because Azure detected that something was wrong with the context of the sign-in. Password alone is not enough anymore. This is the power of identity-based security. This is the central identity platform for Azure. It manages users, groups, applications, access policies. Everything identity related is controlled from here, like Azure Entra ID. Multi-factor authentication. MFA requires a second verification step beyond passwords, especially for privileged accounts. MFA is mandatory. Even if a password is compromised, attackers cannot proceed without the second factor. Least privilege access. This is an important principle. Users should only have the minimum permissions required to do their job. This reduces risk and limits damage. If an account is compromised, it will be having very limited access, like right permissions we have to provide. Like in real world example, imagine an HR employee logs into Azure. They can access HR applications, payroll systems, but they cannot access finance database or production infrastructure. Even though they are a valid employee, their permissions are restricted based on their role. Layer 3, perimeter security. At this layer, Azure focuses on protecting your environment from large-scale external attacks before they even reach your applications. So think of this layer as the first major shield between the internet and your cloud resources. So what is perimeter layer? The perimeter layer is designed to defend against massive network-based attacks, especially those coming from the internet. And here we can tell like distributed denial of services attack, DDoS. Imagine you have a public facing e-commerce website hosted in Azure. Everything is running normally. Suddenly, your website starts receiving 2 million requests per second. But here the problem, these are not real users. They are fake requests coming from the botnet, a network of compromised missions controlled by attackers. The goal is simple: overwhelm your servers, consume all resources, take your website offline. Here what happens in Azure, like this is where like DDoS protection comes into action. It automatically responds in real time. Like Azure performs 3 key actions. Detects abnormal traffic. It continuously monitors traffic patterns. If it detects unusual spikes or suspicious behavior, it immediately flags it as a potential attack. Once the attack is identified, Azure automatically separates legitimate user traffic, malicious bot traffic. Only real users are allowed through. Absorbs the attack. Azure has massive global network capacity. It can absorb the mitigate large scale traffic floods without impacting your application. Even during a massive attack, your website remains accessible. Real customers can continue using the service. Attack traffic is blocked silently in the background. So users may not even realize an attack is happening. Here think like a stadium entrance. If 2 million fake people try to rush into a stadium at once, security at the gates. Detects abnormal crowd behavior, blocks unauthorized entries, allows only ticket holders inside. In the same way, Azure does the network perimeter. If your website receives millions of fake requests from bots, is that a problem at the application level or network perimeter level? The correct answer is perimeter layer, because the attack happens before reaching the application. Perimeter layer protects against DDoS and large scale attacks. Azure DDoS protection automatically mitigates traffic floods. It ensures availability of applications even under attack. If you see like question in AZ-900 exam, website downtime due to a massive traffic, always think like DDoS protection at the perimeter layer. Layer 4 network. At this layer, Azure focuses on controlling how resources communicates with each other inside the cloud. Even if an attacker manages to access one part of your network, they should not be able to move freely to other systems. This concept is called limiting lateral movement. What is network security in Azure? In Azure, network security is achieved by logically separating the controlling traffic between resources. This is done using three key components. Those are virtual networks, VNets, subnets, and network security groups. Private link. Virtual networks, VNets. VNet is like your private network inside Azure. It allows you to isolate your resources, control communication boundaries. It creates secure cloud environments. You can think like it is a private network inside the cloud. Subnets and NSGs inside a virtual network. You can create subnets. Subnets divide your network into smaller segments. Now to control traffic, Azure uses network security groups, NSGs. NSGs act like traffic rules. They decide what traffic is allowed in, what traffic is allowed out, which ports and protocols can communicate. So instead of trusting everything inside the network, Azure enforces strict rules at every level. Next, private link. By default, many cloud services are accessed over the public internet. But with private link, Azure allows you to access services privately without exposing them to the internet. So traffic stays inside Azure backbone network. This greatly improves security and reduces exposure to external threats. Imagine you have a 3-tier application, a web server in subnet A, an application server in subnet B, a database in subnet C. Now you configure NSG rules like this. The web server can talk to the application server. The application server can talk to the database, but the web server cannot directly access the database. See here, web server can talk to application server, application can talk to database, but that web server cannot directly talk to database. Now imagine an attacker compromises the web server in subnet A. What can they do? They are stuck in subnet A. They cannot directly access the database. They cannot move freely across the network. This is lateral movement prevention in action. Even if one layer is compromised, Azure ensures the rest of the environment remains protected. Critical systems like databases stay isolated. Attackers cannot freely move inside your infrastructure. This significantly reduces the impact of a security breach. So here VNet, network isolation, subnets plus NSGs, traffic control rules, private link, private access to services. So here like the goal is prevent lateral movement. If you see, like securing communication between resources, this means network security layer. Layer 5, compute. At this layer, Azure focuses on protecting your virtual machines and compute resources, because in most real world attacks, once an attacker gets access to compute resources like a virtual machine, they try to take full control of the system. So Azure adds strong protections around compute environments. Why compute security is important? Because virtual machines are one of the most common attack targets in the cloud, because they often run web applications, APIs, backend services, databases. So if VM is compromised, the attacker may gain access to critical workloads. That's why Azure applies multiple security controls at this layer. Just in time VM access. Here the idea, by default remote access ports like RDP and SSH are not open. This means attackers scanning the internet cannot find open entry points. Here you can imagine like administrator needs access a virtual machine. Instead of keeping the port open all the time, Azure requires a request for access approval based on policy. Temporary access granted. Once approved, the port opens only for a limited time, usually like 30 minutes or less. After that, the port automatically closes again. So here, whenever administrator requires VM access, then he will raise this JIT VM access. Once he got the access, he can access the VM and then he can do his work. But it will be generally like 30 minutes or less. So after the time is over, that ports will be closed. Secure VM configurations. Azure ensures that virtual machines follow security best practices such as secure operating system configurations, hardened system settings, reduced attack surface. Microsoft Defender for servers. This is Azure's built-in threat detection for virtual machines. It helps detect suspicious activity, identity vulnerabilities, monitor security posture in real time. Automated OS patch management. One of the biggest risks in any system is outdated software. Azure helps by automatically applying security patches. It reducing vulnerabilities in operating system, ensuring systems stay up to date. Endpoint detection and response. EDR continuously monitors the VM for malicious activity, unauthorized behavior, security threats in real time. If something suspicious happens, alerts are triggered immediately. So here think about company hosting a web application on an Azure VM. Without security controls, RDP port might be open 24/7. Attackers could continuously scan and attempt login attacks. But with Azure Compute Security, RDP is closed by default. Access is only granted temporarily via JIT. The system is continuously monitored. Security patches are applied automatically. So even if attackers try, there is no permanent entry point to exploit. So here I'm asking you one question, like if an attacker scans a virtual machine and finds that RDP is not open, what does that indicate? It means just-in-time access is protecting the system by keeping ports closed by default. Here you have to remember compute layer, protection of virtual machines, JIT access, temporary controlled access to VM ports, defender for servers, threat protection for VMs, patch management, it reduces vulnerabilities. Here the goal is reduce attack surface of compute resources. Here if you see questions about securing virtual machines, you always has to think about compute security layer. Data encryption. Data encryption. Even if every other security layer fails, data security ensures your information is still protected. This is why encryption is often called the last line of defense. Why data encryption matters? An attacker somehow gains access to physical storage or copies your data. The attacker cannot read it because the data is encrypted. Without encryption keys, the data is completely unreadable. Azure Data Encryption. This protects virtual machine disks. On Windows systems, it uses BitLocker. On Linux systems, it uses dmcrypt. So even if someone steals the disk or makes a copy of it, the data remains fully encrypted and unusual. Storage service encryption. Now let's move to Azure Storage. All data stored in Azure services is automatically encrypted at rest using AES 256 encryption, including blob storage, file storage, queue storage, table storage. Here, like this encryption is enabled by default, no extra configuration required. So your data is protected automatically. Azure Key Vault. Now the important question is, where are encryption keys stored? This is where Azure Key Vault comes in. Azure Key Vault is used to securely store encryption keys, manage secrets like passwords and API keys, control access to certificates, audit who accessed sensitive information. So instead of hard coding secrets in applications, Azure centralizes them in a secure vault. TLS encryption in transit. Whenever data travels between users and Azure, between Azure services or across networks. It is protected using Transport Layer Security (TLS). This ensures even if data is intercepted in transit, it cannot be read or modified. Okay, let's imagine a hospital storing patient records in Azure. Even if a storage disk is stolen, data is encrypted. Someone accesses storage directly, data is encrypted. Data is transmitted over the network, TLS protects it. Encryption keys are required, protected in Key Vault. So patient data remains secure at every stage, at rest or in transit and controlled through secure key management. So here encryption is the final layer of defense in depth. Data is protected at rest, in transit and in use. Key Vault manages encryption keys and secrets. AES 256 is commonly used for storage encryption. TLS secures network communication. If you see question about stolen data or compromised storage, always you have to think about data encryption layer. Now we are moving into Chapter 4, Azure Governance. So, how do organizations control thousands of resources in a consistent and compliant way? This is exactly what Azure Governance solves. What is Azure Governance? Azure Governance is a framework that helps organizations control Azure resources, enforce rules automatically, maintain compliance, manage cost and structure at scale. Think of it as the rule book for your entire Azure environment. It ensures that every resource deployed follows organizational standards. In real world cloud environments, companies may have thousands of virtual machines, hundreds of applications, multiple departments and teams, different regions and subscriptions. Without governance, resources become disorganized, costs become unpredictable, security becomes inconsistent. So governance ensures control, consistency and compliance across everything. Azure policy. Now let's go deeper into one of the most important governance tools in Azure, that is Azure policy. In large cloud environments, you cannot manually check every resource. So instead, Azure uses automation to enforce rules. This is exactly what Azure policy does. What is Azure policy? Azure policy allows organizations to define rules for Azure resources, automatically enforce those rules, prevent non-compliant resources from being created, detect and flag existing violations. Think of it as a set of guardrails for your cloud environment. It ensures that everything deployed in Azure follows your organization's standards. Why this Azure policy is important? In real world organizations without policies, developers may deploy resources in different regions. Security settings may vary across teams. Costs may become unpredictable. Compliance requirements may be missed. So here Azure policy ensures consistency, security, compliance, cost control. All this automatically. Organization can restrict deployments to specific regions. For example, only allow resources in East US. So if someone tries another region, it is blocked because that security determines that the policy determines only you have to create resources in specific region. Mandatory tags. Every resource must include metadata such as department owner. This helps with cost tracking and accountability. Encryption required. Storage accounts must always have encryption enabled. So no encrypted storage is allowed in the environment. Allowed VM sizes. Organizations can restrict virtual machine types, so controls cost. Standardize performance. Avoid oversized deployments. Imagine a developer logs into the Azure portal. They try to create a virtual machine, but they select Japan East region. However, the organization has a policy only East US region is allowed. Now what happens? It blocks. Azure policy immediately evaluates the request, check compliance rules, blocks the deployment. So the result is the VM creation is denied automatically. So for this, no approval needed or no ticket raised or no manual review required. Azure policy acts before deployment happens. So instead of fixing problems later, Azure prevents problems before they occur. This is called proactive governance. If a developer tries to deploy a resource that violates an Azure policy, what happens? The correct answer is the deployment is automatically blocked because of that policy. So here you have to remember Azure policy, it enforces rules automatically, works as a guardrail system, prevents non-compliant deployments, it helps with security, cost and compliance, no manual intervention required. Resource groups and tagging. What are resource groups and tags? In Azure, resources can quickly grow into hundreds or even thousands. So we need a way to organize them, or track them, manage them efficiently. This is where resource groups and tags come in. Together they form the foundation of a well-managed Azure environment. Resource groups, logical organization. A resource group is a logical container that holds related Azure resources. For example, like for an application, you may have virtual machine, database, storage account, app service, all grouped together inside the resource group. Here, why resource group matters? It helps you organize resources by application or project. It manages life cycle, create, update, delete together. So once we delete resource group. Inside that resource group, all the resources also will be deleted. It applies access control at group level. So instead of managing individual resources one by one, you manage them as a single unit. Tags, metadata for resources. Tags are simple name value pairs attached to Azure resources, but don't underestimate them. They are extremely powerful. They help you add meaning and context to resources. Tags helps organizations achieve. You can group resources logically across subscriptions and resource groups. For example, department equal to HR, project equal to HR portal. So in this way you can apply tags. Billing and cost control. Tags allow you to track exactly where money is being spent. You can filter cost reports by department, project, environment. So you know exactly which team is spending what. Automation. Tags can be used in automation scripts and policies. For example, shut down all VMs with tag environment equal to dev at 6 p.m. This helps reduce cost automatically without manual effort. Let's take a real application, HR portal project. You can apply tags like project equal to HR portal, environment production, department HR, owner IT. Now imagine this at scale across hundreds of resources. You can consistently identify ownership, track spending, automate operations, enforce governance. Resource groups organize resources physically in Azure structure. Tags organize resources logically across the entire environment. One is structural, one is informational. Together they create complete governance visibility. Resource group equal to department, office, HR, finance, IT. Tags, labels and files, project, owner, priority. Even if files are stored in different rooms, tags help you understand what they belong to. So here you have to remember resource groups, logical container of resources. Tags, metadata for cost and organization. Tags help with automation and reporting. Resource groups manage life cycle together. Both are essential but for governance and cost control. Here if you see questions about tracking costs and organizing resources, you have to think about resource groups plus tags. Azure governance hierarchy. This is where like Azure becomes truly powerful at scale. Because in real organizations, you don't manage just 10 or 20 resources. You manage thousands of them across teams, projects and regions. So how do you apply rules consistently everywhere without repeating yourself? That is exactly what the Azure governance hierarchy. What is Azure governance hierarchy? Azure provides a structured hierarchy that allows organizations to apply governance at different levels. This hierarchy includes management groups, subscriptions, resource groups, resources. Each level represents a scope of control. Anything defined at a higher level automatically flows down to lower levels. This is called inheritance. So instead of applying policies again and again, Azure automatically enforces them across everything underneath. How it works in real life? Let's understand this with a practical example. Imagine a company defines a policy at the management group level. This policy says only allow approved VM sizes. Now what happens? This single policy automatically applies to all subscriptions under the management group. All resource groups inside those subscriptions, all resources inside those resource groups. So the rule is enforced everywhere automatically. This is a key benefit of Azure governance. You do not need to apply the same policy multiple times. Configure each subscription individually. Manage each resource group separately. Instead, one policy controls everything below it. This is what makes Azure scalable for enterprise environments. If the company CEO says all employees must follow security training rules, that rule automatically applies to all departments, all teams, all employees. No manager needs to reinforce the same rule again. Azure works exactly the same way. This hierarchy ensures consistent governance across environments. It reduced administrative effort, strong compliance enforcement, scalable cloud management. So even if you have thousands of resources, you still maintain full control. So here you have to remember management group, top level governance. Policies flow downward automatically. Inheritance reduces manual configuration. One policy can control thousands of resources. Threat protection. What happens when attackers still try to break into your environment? Because in the real world, attacks are not theoretical, they are constant. That's where Azure's threat protection system comes into play. What is threat protection? Threat protection is in Azure is about detecting attacks in real time, identifying suspicious activity, providing security recommendations, automatically responding to threats. So instead of just preventing attacks, Azure also focuses on detecting and responding to active threats. Microsoft Defender for Cloud. If you remember one idea from this slide, like it should be the security is not just about prevention, it is about continuous monitoring, detection and improvement. That is exactly what Microsoft Defender for Cloud providers. What is Microsoft Defender for Cloud? Microsoft Defender for Cloud is Azure's unified security management and threat protection platform. It continuously monitors your cloud environment and helps you understand what is secure, what is risky, what needs improvement. So instead of reaching after a breach, Azure helps you stay ahead of threats. Secure source. Let's start with one of the most important concepts, that is secure score. Secure score is a numerical representation of your security posture. It ranges from 0 to 100%. Higher score like stronger security posture, lower score will be higher risk exposure. Every security recommendation you implement increases your score. So it works like a security improvement database. Every security recommendation you implement increases your score. So it works like a security improvement dashboard. It tells you exactly how secure your environment is and how to improve it. Threat detection. Now let's talk about threat detection. Microsoft Defender to Cloud continuously monitors your environment in real time. It looks for suspicious login activity, exposed ports and misconfigurations, malware or malicious behavior, unusual resource usage patterns. If something looks abnormal, it immediately generates an alert. So instead of waiting for damage to happen, Azure detects threats as they occur. Actionable recommendations. Now here is where Defender for Cloud becomes very powerful. It doesn't just say there is a problem. It tells you here is exactly how to fix it. These are called actionable recommendations. They are prioritized based on risk. So even security teams know exactly what to fix first. Multi-cloud support. Now let's look at something very important for enterprise environments. Microsoft Defender for Cloud is not limited to Azure. It also provides security visibility for Amazon Web Services, Google Cloud Platform. So organizations can manage security across multiple cloud providers from a single dashboard. This gives a unified security view across all cloud environments. So here you have to remember Microsoft Defender for Cloud, security posture plus threat protection, secure score 0 to 100, security rating, provides real-time alerts and recommendations, supports Azure, AWS and GCP, focuses on continuous improvement. If you see questions about security monitoring or posture management, the correct answer is Microsoft Defender for Cloud. Automated threat response. This is where Azure moves from just detecting threats to actually responding to them in real time. And let me start with the key idea. In cyber security, speed is everything, because the longer a thread stays active, the more damage it can cause. Why automated response matters? In additional security environments, the process usually looks like this. Detect a thread, send an alert, wait for security engineer, investigate manually, and then take action. This process can take hours, but in modern cloud security, the delays is not acceptable. So, consultant. It continuously analyzes your Azure environment and provides recommendations, best practices, optimization suggestions, actionable guidance. So instead of guessing improvements, Azure tells you exactly what to fix and why. The 5 pillars of Azure Advisor. Cost optimization. Azure Advisor helps reduce unnecessary spending by identifying idle or unused resources. Overall provisioning, virtual machines, opportunities for resizing resources, wasteful configurations. So you only pay for what you actually use. Security. In security, Azure Advisor works with Microsoft Defender for Cloud to identify security misconfigurations, highlight vulnerabilities, recommend security hardening steps, so your environment becomes more secure over time. Performance. Azure Advisor improves application efficiency by identifying latency issues, recommending performance improvements, suggesting resource scaling or optimization. This ensures better user experience and faster applications. Reliability. Reliability focuses on keeping systems available and stable. Azure Advisor recommends high availability configurations, backup strategies, disaster recovery improvements, availability zone usage. So your applications stay online when during failures. Operational excellence. This pillar focuses on improving how you manage your environment. It recommends automation opportunities, better deployments practice, process improvements, operational efficiency enhancements. So teams work smarter, not harder. So let's understand this with a simple real world scenario. Azure Advisor detects a virtual machine running 24/7 with no real usage. It analyzes the usage pattern and recommends shut down or resize the VM. Business impact. After following the recommendation, the organization saved $500 per month instantly. No complex optimization work required, just actionable guidance. Azure Advisor is not just monitoring, it is a continuous optimization engine. A cloud cost and performance advisor, a best practices recommendation system. It helps organizations improve continuously without manual analysis. Real world analysis. Like think of Azure Advisor like a personal financial advisor. It reviews your spending, identifies waste, suggests saving opportunities, helps you make smarter decisions. DevSecOps. This is where everything we learned so far comes together. Identity, security layers, governance, compliance, monitoring, threat protection. Now we apply all of that into the software development lifecycle. What is DevSecOps? DevSecOps means development plus security plus operations. It is the practice of integrating security into every stage of application, development and deployment. So instead of treating security as a final step, security becomes part of the entire life cycle. Traditional versus DevSecOps approach. In the traditional model, developers write code, operations deploy it, security checks happen at the end. This causes delays and data late discovery of vulnerabilities. In DevSecOps, security is built in from the beginning, so vulnerabilities are detected early before production. Shift security left. Now let's focus on one of the most important modern security practices in DevSecOps. Shift security left. Shifting left means moving security earlier in the software development lifecycle. What does shift left mean? In traditional development, security checks happen at the end, just before production. But the problem is, by the time a vulnerability is found in production, it is expensive, risky, and time consuming to fix. So shift left changes this approach. Instead of waiting until deployment, security is applied during coding and build stages. This means issues are caught early when they are easiest to fix. Why shift left is important? Shift left helps organizations detect vulnerabilities early, reduce security risks, lower fixing costs, prevent production incidents, improve overall code quality. So security becomes proactive, not reactive. Microsoft Defender for DevOps. Azure supports shift left using Microsoft Defender for DevOps. This integrates directly into CI/CD pipelines and development tools to continuously scan code and infrastructure. Terraform and ARM template scanning. One key capabilities is infrastructure as code scanning. It analyzes Terraform scripts, ARM templates. It detects misconfigurations. It security risks before deployment. So infrastructure issues are fixed before resources are even created. Secret detection. Another critical feature is secret detection. It identifies hard-coded passwords, API keys, authentication tokens. Sometimes developers accidentally commit these into repositories. Azure detects them immediately and flags them as a security risks. Dependency scanning. Modern applications use open source libraries, but some of these libraries may have known vulnerabilities. So dependency scanning helps by identifying vulnerable packages, checking known CVEs, common vulnerable and exposures, recommending secure versions, This protects the application supply chain. Shift left security early in SDLC. Uses CI/CD pipeline integration. Defender for DevOps scans code and IAC. Detects secrets, vulnerabilities and misconfigurations. Blocks insecure deployments automatically. So here if you see a question about early security testing or DevOps security, the correct answer is shift left security. Zero trust. Zero trust is a security philosophy and it completely changes how we think about security in the cloud. What is zero trust? Zero trust is built on one simple principle: never trust, always verify. In additional security models, once a cluster is inside the network, they are often trusted automatically. But in today's cloud world, that assumption is dangerous. So, zero trust assumes threats can exist both inside and outside the network. Zero trust principles. Zero trust is not a single technology or product. It is security model built on one simple rule: never trust, always verify. Why zero trust exists? In traditional security models, once a user is inside the network, they are often trusted automatically. But in modern cloud environments, the assumption is no longer safe. Zero trust assumes that threats can exist outside the network. Threats can also exist inside the network. Therefore, every access request must be verified. Verify explicitly. This means every access request must be authenticated and authorized using all available signals. These include identity, location, device health, service or workload identity, risk level and behavior. So access is not based on network location or assumptions. It is based on real-time verification. Use least privilege. Least privilege access. This means users are only give the minimum permissions required to do their job, nothing extra. Azure enforces this using just-in-time access, just enough access policies. So even if an account is compromised, the attacker cannot move beyond limited permissions. This reduces impact significantly. Assume breach. This means we design systems as if an attacker is already inside the environment. So instead of trying to prevent all breaches, we focus on limiting damage and detecting threats quickly. This leads to strong segmentation, encryption everywhere, continuous monitoring, fast threat detection and response. How zero trust works during a login. When an employee logs in, Azure evaluates identity verification, device compliance status, location risk, behavioral risk signals. Dynamic access decision. Based on this evaluation, Azure grants only the minimum required access for that specific task. So access is context based, risk aware, continuously evaluated. Think of zero trust like entering a secure airport zone. You don't just show your ID once. Instead, you are verified at multiple checkpoints. Access is granted based on clearance level. Restricted zones require additional validation. Monitoring continues throughout your movement. Trust is never permanent, it is always verified. In zero trust, does Azure grant full access after a successful login? No, access is continuously evaluated and limited to minimum required permissions. So here you have to remember, verify explicitly, check identity, device, location, risk, least privilege, minimum required access only. Assume breach, design for compromise, use JIT or ZEA. Access models. Access is dynamic and continuously evaluated. If you see question about modern security approaches, the correct answer is zero trust principles. Now let's wrap up with some important AZ-900 exam tips. This section is not just about theory, it's about how you should think during the exam, because AZ-900 is not a memorization exam, it is a scenario based concept exam. So your goal is to identify the correct Azure service or concept for each situation. Always focus on understanding concepts, not on memorizing technical syntax or commands. So here you have to remember shared responsibility model. You must clearly understand what Microsoft manages, what you manage, IaaS, PaaS, SaaS. Responsibility decreases as you move from IaaS to SaaS. So in SaaS, Microsoft manages almost everything. You only manage users and data access. Entra ID and MFA. Next, focus on identity services. You should understand single sign-on, multi-factor authentication, conditional access policies, B2B versus B2C, identity scenarios. Defense in depth. You must know all 6 layers in order: physical, identity, perimeter, network, compute, data. Next, Azure policy and governance. Policy assignments at management group or subscription level, inheritance hierarchy, management group to subscription, and resource group plus resource, tagging for cost tracking and automation. Microsoft Defender for cloud, secure score, threat protection and alerts, security recommendations, multi-cloud supports, Azure, AWS, GCP. It continuously improves your security posture. Compliance and zero trust. Finally, remember global compliance and security models. Zero trust principles. Verify explicitly, least privilege, assume breach. Now let's close part 3 with the key takeaways you should remember for both AZ-900 exam and your real world Azure journey. These are the core ideas that tie everything together. If you remember only a few concepts from this entire section, make sure it's these. Identity is the new perimeter. The first key idea is identity has replaced the traditional network perimeter. In the past, security was focused on firewalls and network boundaries, but in the cloud era, users connect from anywhere, devices are unmanaged, applications are globally accessible. So security now revolves around identity. That's why Microsoft Entra ID, multi-factor authentication, conditional access have become the first line of defense. Defense in depth, layers protection. Azure uses a defense in depth model with 6 layers: physical, identity, perimeter, network, compute, and data. So even if one layer is compromised, other layers continue to protect the system. This ensures no single point of failure. Governance enforce standards at scale. Governance ensures consistency across the entire Azure environment with Azure policy, resource tagging, management group, hierarchy. Organization can enforce rules automatically across thousands of resources. So instead of manual governance, Azure enforces compliance at scale. This reduces errors and improves control. Zero trust assumes breach. You should never assume trust, always verify. Zero trust is based on 3 principles: verify explicitly, use least privilege, assume breach. This means every access request is validated. Users get only minimum required permissions. Systems are designed to limit damage if compromised. So security is built for a world where breaches are always possible. So when you bring everything together, Azure security is built on 4 major ideas. Identity is the control plane, security is layered with defense, governance is automated with Azure policy, and zero trust ensures governance verification. So in part 4, we will explore the core building blocks of Azure. Build applications, store and manage data, connect networks, scale workloads, automate processes. So this is where theory runs into real world architecture. There we will start with compute. This includes services that you run applications, virtual machines, Azure App Service, Azure Functions, container instances. And then storage and database, blob storage, file storage, queue storage, table storage. And then database services like Azure SQL Database, Cosmos DB. These are used to store structured and unstructured data at scale. Networking, virtual networks, load balancers, VPN gateway, express route. Azure CDN. These services will help you connect resources securely and efficiently across regions and users. AI container and serverless. Finally, we explore modern cloud innovation services: Azure AI services, Azure Kubernetes service, Azure Container Apps, Azure Logic Apps. Thank you for watching. What you have achieved at this stage, you know, have a strong foundation in Azure's layered security model, identity and access management with Microsoft Entra ID, governance using Azure policy and tagging, global compliance standards and certifications, monitoring threat protection and DevSecOps, modern zero trust security architecture. If this video helped you understand Azure better, please give it a like. It helps support the channel and reach more learners. Comment section, if you have any questions or insights, drop them into the comments below. We read every comment and try to help you learn better. Subscribe. Don't forget to subscribe to stay updated. Part 4 is coming next, where we will explore real Azure services used in production environments. Keep learning, keep building, and I will see you in part 4. Thank you.